Thank you for watching Hack the File. I'm Michael Lopez, and on today's episode, we're going to be doing the next video in the Linux Basic for Hackers. Enjoy. All right, let's get things started. You know the routine. This is going to be Chapter 5, Controlling File and Directory Permissions. All right, not every user of single operating systems should have the same level of access to files and directories. Like any professional or enterprise level operating systems, Linux has methods for securing files and directory access. This security system allows the system's administrator to root user or the file owner to protect their files from unwanted access or tampering by granting selected users permission to read, write, or execute files. For each file and directory, we can specify the permission status for the file owner, for particular groups or users, and for all other users. This is a necessity in a multi-user enterprise level operating system. The alternative would be quite chaotic. In this chapter, I'll show you how to check for and change permissions on files and directories for select users, how to set default file and directory permissions, and how to set special permissions. Finally, you will see how a hacker's understanding of permissions might help them exploit a system. Different types of users. As you know, in Linux, the root user is all powerful. The root user can do basically anything on the system. All other users on the system have more limited capabilities and permissions and almost never have access to the root user has. These other users are usually collected into groups that generally share a familiar function. In commercial entities, these groups might be finance, engineering, sales, and so on. In an IT environment, these groups might include developers, network administrators, database administrators. The idea is to put people with similar needs into a group that can be granted permissions. Then each member of the group inherits group permissions. So it's primarily for the ease of administrative purposes and thus security. The root user is part of the root group by default. Each new user on the system must be added to a group in order to inherit the permissions of that group. Granting permissions. Each and every file must be allocated a particular level of permissions for different entities using it. The three levels of permissions are as follows. R, permission to read. Now this is all very important, and I love this book. Permission to read. This grants permission only to open and view a file. W, permission to write. This allows users to view and edit a file. X, permission to execute. This allows users to execute a file, but not necessarily view or edit it. So you probably have to have RWX. In this way, the root user can grant users a level of permission depending on what they need the files for. When a file is granted, typically the user who created the owner of the file, the owning group is the user's current group. Yeah, I read that wrong. The owner of the file can grant various access privileges to it. Let's look at how to change permissions to pass ownership to individual users and groups. Granting ownership and individual users. To move ownership of a file to a different user so that they can have the ability to control permissions, we can use this is the change something. So chown or change owner. Change own. So chown command. I've never used this one. Let's try that. Chown Bob/temp. But I don't have any users, and I'm going to create a user. Here we give the command the name of the user we are giving ownership to, and then the location and the name of the relevant file. This command grants the user account for Bob the ownership of Bob's file, and then it's in temp Bob's file. So we can probably create Bob as a user and then put Bob's file in a temp folder on the desktop. Let me see if they're going to have us do. Let's just see what happens when we do that. Sometimes it creates it. So let's go here, and where is my. Okay, we're going to create a file called Bob's file on the desktop, right? I'm going to open the terminal here, and I'm going to say change own Bob. It's going to say there's no username Bob. Was it Bob's file? See, there's no username Bob, so I think it's add user Bob. Oh, I did that command line kung fu again. Oh, that's cool. Hold on. There you go. Command line kung fu. What the heck? I don't know what that is, but because I've never done it. But I'm gonna bring this over here and see if it's. I don't want you to know my password, or whatever password it's asking me. Hold up. Guess I didn't have to do that. So apparently I created Bob, the user. So now I can change owner. Cannot access Bob's. No such file in the directory. Can I access file? Okay, so this has to be one word. Or what? Changing ownership of Bob's file. Operation not permitted. Command line kung fu. Sudo. Now I change ownership to Bob. Alright. Dang Linux. So it says it's locked to ownership. Alright, let's see what else happens. So we did that, we figured that out. Here we give the command the name of the user we are giving ownership to and the location. This command grants user account for Bob, ownership of Bob's file. Getting ownership to a group. To transfer ownership of a file from one group to another, we can use the change group command. Hackers are often more likely to work alone than in groups, but it's not unheard of several hackers or pen testers to work together on a project, and in that case, using groups is necessary. For instance, you might have a group of pen testers and a group of security team members working on the same project. The pen testers in this group are the root group, meaning they all have permission and access. The root group needs access to the hacking tools, whereas the security folk only need access to defensive tools such as intrusion detection systems, IDS. Let's say that the root group downloads and installs a program named new IDS. The root group will need to change the ownership of the security group so the security group can use it at will. To do so, the root group would simply enter in the following command: change group security new IDS. I don't have any groups, but I can add group, right? It's probably gonna have us do all this here in a minute. Let's see. Alright, let's see if we can add group. Yeah, that's not gonna work because then I have to add a group and then I have to add that permission. We'll have to add the new IDS. I don't know what that is. The root group needs access to the hacking tools, where the security folk need access to the defensive tools. Let's say the new group downloads and installs a program named new IDS. So let's do I have a program? I'm just gonna say the group can access the Bob's document, right? So let's make a group called security. All right, let's see if we can do that. Where is that at? How did I add the new add group? Didn't work. New group. Oh, there you go. Nope. Let me see. New group. Wait, hold up. Sudo new group. What was it? Security. Security. New group. Group security does not exist. Add new group. Yeah, I'm just gonna Google this real quick. I don't know how to do it. I'm just guessing. Group ad. Group ad. Group name. That was close. I'm just gonna copy that. Am I pressing on something? What the hell? What the hell? Let me see. Pseudo and what the? That's the one I just put. That's ridiculous. And that copy. Man. Did I already close that dang window? Pseudo group ad. All right, we added a new group. Remember that's group ad. It was close. Um. Now what do we want to do? We want to change group security. We're gonna give them Bob's. So CH group. We're gonna give them Bob's access. So CH group. Sudo. Now that group has access to Bob's file. Can I access Bob's file? Yeah, because I'm root. Wow. Alright, so that looks like it worked. This command passes the security group ownership of the new IDs, or I use Bob's file. Now you need to know how to check whether these allocations have worked. You'll do so by checking a file's permissions. Checking permissions. When you want to find out what permissions are granted to what user for a file or directory, use the ls command with the -l long. Switch to display the contents of a directory in a long format. This list will contain the permissions in listing 5.1. I use the ls-l command on the file user share hashcat, one of my favorite password cracking tools, in order to see I can learn about the file. So we're going to do that. We're going to check the Bob's file, right? ls-Bob's file. So you can read, write, write, write. One Bob, one Bob security zero me. What does that mean? So security has access to Bob? It did something. Gave me a number and everything. So let's see what it did. I mean, this is fun, but you know. All right. Well, that's what it did. On each line, we get information about the file type. This is the first character listed. So the permission on the file, the permissions on the file for owner, groups, and users respectively. This is the rest of the section. The number of links. This topic is beyond the scope of the book. Really? Got one link. The owner of the file. Root. Let's see what it says on the owner of the file. It's Bob, right? Bob is the owner or security is the owner? There's the links. Can't execute that. Well, you don't need. You can't execute it because it's just a document. Ah, God, I just. All right, let's see. Where's the? Where am I going? Man, I'm tired. All right. I don't know what I just clicked on. Just clicked everything off. Here you go. Okay. The size of the file in bytes. When the file was created or last modified, the name of the file. So, yeah. So, this is all the read and write, whatever. Links, I guess. Owners. Bob is, or security is the owner. May 9th. This is the name of the file. We're gonna have to look at that better. I don't know. Let's see. Man, what's going on? Why is this? Man. For now, let's focus on the seemingly incomprehensible string of letters and dashes on the left edge of each line. They tell us whether an item is a file or directory, and what permissions, if any, are on it. The first character tells you the type of file, where D stands for a directory and a dash indicates a file. These are the two most common file types. The next section defines the permission of the file. There are three sets of three characters made of some combination of read, write, execute, in that order. The first set represents the permission of the owner. The second set is those of the group. And the last is those of the users. Regardless of which set of the three letters you're looking at for the file, you will see an R first. That user or group of users has permission to open or read the file or directory. A W as the middle letter means that they write, modify the file, and an X at the end means they can execute or run it. A file or access directory. If any RW or X is replaced with a dash, then the respective permission hasn't been given. Note that users can have permission to execute only either binaries or scripts. Let's use the third line of the output as an example. Alright, so let's look at what happened to mine. So this dash, first, second, third. So it's a document. That's the owner, user, and group. What was it again? The first character tells the file type. Where D, where's D at? Let's see no D on here. Dash indicates a file. So if it would have said D, but this is a file. File. These are the two most common types. The next section defines the permission on the file. There are three sets of characters made of some combination of R, W, and X. So this is just R, W, in that order. The first set represents the permission of the owner. So this is the owner, right? It means the owner can read and write, and it's a file. The second of those is the group, so the group can just read it. What the hell is this dash dash right here? Dash dash. I'm confused. Regardless of which set of the three letters you're looking at. Oh wait. And those are the and the last is those of the users, so any user can just read too. So I'm thinking that this dash means it's the file, and the front of it is the dash of this one. Man, that's confusing. So this here is the owner can read and write, and it's a file. And then this one is the group can just read it, and it's a file. I don't know. And then this one right here, why does it got two dashes? Maybe just one? Man. So file, and it can only read it, the user. I'm just going to see it like it's a file, and then you can only read it if you're a user in the group. Root, hashcat. I guess we'll find out more as we read. The file is called, as we know, from the right end of the line, hashcat by the initial, which indicates it's after the initial. Okay, the file is called, as we know, from the right end of the line, hashcat stat after the initial dash, which indicates it's a file. The permission RW. Oh, okay. So this, yeah, like I said, file RW dash tells us that the owner has read and write permissions, but not execute permission. So it's missing the X. That dash, I guess, it's missing the X. That's what that dash is. Okay, that makes sense. The next set of permission is the R dash dash. Represents those of the group and shows that the group only has read permission. That makes sense. So it's missing the write and the read. And finally, we see the rest of the users also have only read permission. So the same thing. It's missing that. All right. That cleared it up real nice. You learn something new every day. These permissions aren't set in stone as a root user on the file. Okay, so let's see what mine was again. So this is a document. The owner, I guess the root can read and write. But he can't execute because it's just a document, so it doesn't execute. Then the group was the next one. That one can only read, can't execute, can't write. And then the users can only read, but he can't execute, can't write. Bob is the original owner, but he's giving permission to security. And I don't know what this is. They haven't done anything. It's called by file. That's a lot of information off of like one little command. That's pretty cool. Alright. You can use the Linux commands change mod or change mod to change the permissions. Only a root user or the file's owner can change permissions. In this section, we use change mod to change. I've done this before to change permissions on the hashcat hashtag. Use two different methods. First, we use a numerical representation of permissions, and we use a symbolic representation. Change your permissions with a decimal notation. We can use a shortcut to refer to permissions by using a single number to represent one RWX set of permissions, like everything underlying the operating system permissions. We are represented in binary, so on and off switches are represented by 1 and 0. Respectively, you can think of RWX permissions as three on and off switches. So when their permissions are granted, they equally represent 111. A binary set like this is easily represented as one digit by converting it into an octal, an 8-digit number, a system that starts with 0 and ends with 7. An octal digit represents a set of three binary digits, meaning we can represent an entire RWX set with one digit. It contains all possible permissions, combinations, and their local and binary representations. We're changing to an octal. Well, nothing is 0. Binary to 1. Octal number 2. Right. Octal number 3. So this is the one we want. Octal 7 is 111. Okay, that makes sense. Using this information, let's go through some examples first. We want to set only the read permission. We would consult and locate the value of read. 100 octal 4. Next, if we want to set the permission WX 3. What? Okay, WX, we could use the same methodology and look for what sets the W and what sets the X. But what is the WX right there? What do you want to do? The WX right there. Where's W? 2, 1, 21. 21. So it'd be dash 21. Notice that the octal representation for WX is 3, which not so coincidentally happens to be the same value we get when we add the two values set in W and X visually. Finally, when all three permissions are on, it looks like this. It looks like this. 421, and 4 plus 2 plus 1 equals 7. Oh man, mira the octal number in effect. Here we see that in Linux, when all the permission switches are on, they are represented by the octal equivalent of 7. Awesome. So if we wanted to represent all that's why it's 777. That's crazy. So if we wanted to represent all permissions for the owner, root, and users, we could just write it as follows: 777. That's very, very, very good to know, because I was like, where does that number come from? Here's where the shortcut comes in by bypassing change mod 3 octal digits, one of each set, followed by a file name. We can change permissions on the file for each type of user, entering the following command or command line. Change mod 774. Let's see. Change mod 774. Oh yeah, now they can read, write, and execute. Well, how can you rewrite and execute if it's a document? Can you execute a document? I didn't know you could. I guess you can. That's just for everybody then. Alright, let's see. Mm-mm-mm-mm. That's exactly what I see. You should see this, and that's what I see on the left side of the hashtag line. This confirms that the change bond call successfully changed permissions to the file to give both the owner and the group the ability to execute the file. Changing permissions with Yugo. Although the numeric method is probably the most common method for changing permissions in Linux, some people find change bond's symbolic method more intuitive. Both methods work equally well, just the one that suits you, do it. The symbolic method is often referred to as Yugo syntax, which stands for the user or owner group and others. Yugo syntax is very simple. Enter the change mod command and then the user you want to change permissions for. Provide the U for users, the G for group, and or for the others, followed by one of the three operators. Removes a permission, adds a permission, sets a permission. After the operator, include the permission you want to add or remove, and finally the name of the file to apply it to. So if you want to remove the right permissions from the user that the file hashcat belongs to, you can enter in the file name change mod user dash right hashcat. What? This command says to remove the right permission from hashcat from the user. So user to remove. Okay, this command says to remove, so that's the minus, yeah. User remove right from there. Now, when you check the permissions with the ls again, you should see that the hashcat file no longer has right permissions for the user. And it came out like that. Program user is gone. Doesn't have the right permissions. Let's use Yugo. Sudo. Well, what was it? Sudo what? Change mod. So we're still in change mod. Change mod. User. Take out that. And then the Bob's file. Then we're gonna run this Bob's file. And it's gone. So right and then the read right's gone on there. But isn't this for all users now? Yeah, because it said it to all users, but why is it just the user? I mean, oh, right here? Yeah, read, write, execute. Let me see, does that look the same? Here it is. Yeah, it looks the same. No? You can also change multiple permissions with just one command if you want to give both the user and other users, not including the group, execution permissions. You can enter the following: change mod user plus add executions, comma other plus add that. Alright, that's simple enough. I'm not gonna do that. I don't have another. This command tells Linux to add the execute permission for the user and execute permissions for other hashcat file for others in the hashcat file. Giving root execution permission on a new tool. As a hacker, you'll often need to download new hacking tools. But Linux automatically assigns all files and directories default permissions of 666 and 777. Respectively, this means that by default, you won't be able to execute a file immediately after downloading it. If you try, you'll usually get a message saying something like permission denied. For these cases, you'll need to give yourself root and execute permissions using change mod in order to execute the file. For example, say we download a new hacker tool called new hacker tool and place it in the root user's directory. ls boom total it. Where's it at? New hacker tool. You can see new hacker tool at 1 along with the rest of the contents of the root directory. We can see that our new hacker tool doesn't have execution permissions for anyone. It doesn't. There's no X's in there. Where's that? It might seem strange that by default Linux won't let you execute a file you downloaded, but overall this setting makes your system more secure. We can give ourselves permission to execute new hacker tool by entering the following: change mod 766 new hacker tool. But I don't have no new hacker tool. So we're not going to do that. Now, when we perform a long listing on the directory, we can see the new hacker tool has execute permission for the owner. New hacker tool. Nice. As you now understand, this grants us as the owner all permissions, including execute, and grants the group and everyone else a read-only permission. Let me see, how long is this chapter? Oh, we're almost done. Setting more secure default. Permissions with masks. As you have seen, Linux automatically assigns base permissions using 666, file 777 for directories. You can change the default permissions allocated to files and directories created by each user with the unmask or user file creation mask method. The unmask method represents the permission you want to remove from the base permissions on a file or directory to make them more secure. The unmask is a 3-digit octal number corresponding to the 3 permissions digit, but the unmasked number is subtracted from the permissions number to give the new permission status. This means that when a new file or directory is created, the permissions are set to the default value minus the value in unmask. For example, if the unmask is set to 22, a new file with the original default permissions of 666 will now have the permission 644, meaning the owner has both read and write permissions, and the group and all the other users have only read permission. In Kali, as with most Debian systems, the unmask is pre-configured to 22, meaning the Kali default is 644 for files and 745 for directories. Unmask value is not universal to all users on the system. Each user can set personal default unmask user for files and directories in their personal.profile. To see the current value when logged in as a user, simply enter in the command unmask and note what returned. To change the unmasked value for a user, edit the home username profile and example, add unmask 007 to set it so only the user members. Let me try unmask. Unmask? That's what unmask does. I don't know what. Ooh. Probably when you're doing this. Okay, special permissions. In addition to the 3 general purpose permissions, read, write, and execute. Linux has three special permissions that are slightly more complicated. These special permissions are set user ID or SUID, set group ID or SGID, and sticky bit. I'll discuss each in turn in the next three sections, granting temporary root permissions with the SUID. As you should know by now, a user can execute a file only if they have permission to execute the particular file. If the user only has read and write permissions, it can execute, and it might be straightforward, but there are exceptions to the rule. You may have encountered a case in which file requires the permissions of the root user during execution for all the users, even those who are not root. For example, a file that allows users to change their password should need access to the etc shadow file, the file that holds users' passwords. Remember that. In Linux, which requires root user privileges in order to execute, in such a case, you can temporarily grant the owner's privileges to execute the file by setting up the SUID bit on the program. Basically, the SUID bit says that any user can execute the file with the permissions of the owner, but those permissions don't extend beyond the use of that file. To set the SUID bit, enter a 4 before the regular permissions. So a file with a new resulting permission of 644 is represented as 64644 when the SUD bit is set. Setting the SUD on the file is not something a typical user would do, but if you want to do so, you'll use the changement command as in changement 4644 file name. Granting the root user's group permission, SGID. SGID also grants temporary elevated permissions, but it grants the permissions of the file owner's group rather than the file owner. This means that with the SGID bit set, someone without execute permissions can execute a file if the owner belongs to the group. Oh, that's cool. That has permissions to execute the file. The SGID bit works slightly different when applied to a directory. When the bit is set to a directory, ownership of the new files created in the directory goes to the directory's creator group, rather than the file's creator group. This is very useful. When a directory is shared by multiple users, all users in the group can execute the files, not just a single user. Oh, that's cool. The SGID is represented as 2 before the regular permissions, so a new file with the resultant permissions 644 represented as 2644. When the SGID bit is set, again, you can use a change my command for this, for example. So the biggest thing I'm taking away from this is the change mod. You can look up all these other real quick on Google if you don't have them memorized. If you're like not constantly using Linux, which if you're wanting to go through this book like me, it means and you want to be like a Linux when you're constantly using Linux at work, or you're just constantly using Linux for anything, then you're probably gonna memorize all this anyways. So I'm just gonna read it, do like I'm doing, but the biggest thing I'm trying to remember is the change mod, right? Because I can always Google these special permissions list, or I can print it out and whatever. The out modded sticky bit. The sticky bit is a permission bit that you can set on a directory to allow a user to delete or rename files um, within that directory. However, the sticky bit is a legacy for older Unix systems. A modern system like Linux ignores it. As such, I will not discuss further. Special permissions, privilege escalations, and the hacker. As a hacker, these special permissions can be used to exploit Linux systems through privilege escalation, whereby a regular user gains root system admin privileges and the associated permissions. With root privileges, you can do anything on the system. One way to do this to exploit a SUID bit A system administrator or software developer might set the SUID bit on a program to allow the program access to files with root privileges. For instance, scripts that need to change passwords often have a SUID bit set. You, the hacker, can use that permission to gain temporary root privileges. Yeah, that's right. And do something malicious, such as get access to the passwords at the etc shadow file. Let's look at files with the SUD bit set on your Kali system to try this out. Back to chapter 1, I introduced you to the find command. We use this power to find files with the SUD bit set. As you'll remember, the find command is powerful, but the syntax is a bit more complicated than some other location commands, such as locate and which. Take a moment to review the find syntax in chapter 1 if you need to. In this case, we want to find files anywhere on the file system for the root user or other system admins with the permission 4000. To do this, we can use the following find command. Let's do that. Alright, let's do this. Find user blah blah. I'm gonna have to move this over here because I'm not gonna remember all that. Go to bam. Alright. I'm gonna use the find command. Find user root perm mission denied. Won't let me go in the lost and found. Let's do it should give me everything now. I actually want to put that in my hack the file. Okay, so let's get that command put in there. That's a good command to remember. So let's see, what is it? Let's call this privilege escalation. Man, I can't spell. I can't ever spell right, man. Privilege. There you go. I'll come in here and then I'm going to create a new file. I'm going to say root find command. Root find command. And then we'll open that. We'll say I don't know. Right? the heck? And then we'll do a comment here. Then we'll say find user root perm 4000. That's it. Save, close. Now it's in there. All right, let's see what this is. That's a cool little command. Now let's go back to this. All right. With this command, we can use Kali to start looking at the top of the file system with the syntax, with that syntax. It then looks everywhere below for the files that are owned by root, specified with user root, and that have the SUID permission bit set perm 4000. When we run this command, we get an output shown like this: user bin, wherever, finding files with the SUID bit set. The output reveals numerous files that have the SUID bit set. Let's navigate the user bin directory. Let's navigate to the user bin directory, where many of these files reside, and then run a long list on the directory and scroll down to the sudo file. cd user bin, long list, cd user bin. So we're going to get into the user bin. That's not going to work. Oh, I'm in the desktop still. Maybe you probably want to come here and home. Computer. What did it say? ls minus. Do the long list. Then it wants then run the long listing on the directory and scroll down to the sudo file. Sudo file. Scroll down to that sudo file. Looking for the sudo file. Here it is. Sudo. Okay. And it's got read, write, SR. It's got everything. Root, sudo. Identifying files. Okay. Note that one, the first set of permissions for the owner has an S in the place of an X. This is how Linux represents that the SUID bit is set. Oh, nice. This means that anyone who runs the sudo file, this means that anyone who, this is important. This means that anyone who runs the sudo file has the privileges of root user. So, well, yeah, which can be a security concern for the system admin and potential attack vectors for the hacker. For instance, some applications need to access the etc shadow file for successfully completing their task. If the attacker can gain control of the application, they can use that application's access to the password on the Linux system. Linux has a well-developed system for security that protects files and directories from unauthorized access. An aspiring hacker needs to have a basic understanding of these systems not only to protect their files, but also to execute new tools and files. In cases, hackers can exploit the SUID and SGID permissions to escalate privileges from regular users to root users. This was an awesome chapter. Now, the thing is, if you're on Hack the Box or something like that, or Try Hack Me, they have you do stuff like this, and they kind of explain the SUID vulnerability and the SGID vulnerability, and they have you find the flag and stuff. But it's only coming back to me now as I'm reading this chapter. This makes more sense to me how that is exploited, because it teaches you how to set up the permissions, and it's teaching you why people would use change mod to to change the to give different permissions, and then it lets you know that the SUID, I guess, command is a special permission, right? And it lets you know that this is how hackers use escalated privilege escalation methods. So, I mean, this chapter is awesome. I love it. I mean, this is just, and what you can do is you can go through it a bunch of times. If you don't understand it quite, go through it a bunch of times till you understand it. Practice it, right? I don't understand it perfectly, but I'm gonna go through back and play with it a little bit more, and I guess I could have simulated this, but like, let me look at this. So yeah, so the S, we ran a find command to find all the actually, we just went to user bin and wanted to see what was in the user bin. So technically I can come and look right here and see what else files have the S file. All right. Right here, look. So there's an S right here, right? That's your G password? What is that? I mean, is that the program? What does that say? John password share. Who's John? No, I'm just kidding. That's John the Ripper. I'm sure of it. Um, and you could just keep looking. So I somewhat have an idea of what's if I was to do privilege escalation, I would get so here's another one, PKEXEC. It's got the SUID special permissions on it. It's root. So these are all the users. So I mean, it gives you an idea of how that works and how hackers are doing it, and I love it. So we'll go back and do the summary. So Linux use of permissions to protect the users or group files and directories from other users in the system can be used for offensive and defensive purposes. You should now know how to manage these permissions and how to exploit the weak points in this system, the security system, in particular SUID and so. Before you move on to chapter 6, put the knowledge you learn in this chapter to test by completing the following exercises. Select a directory and run a long. So you guys can pause this and do it yourself. Select the directory and run a long list on it. Note the permissions on the files and directories. Select a file you don't have permission to execute, and give yourself executing permission using the chmod command. Try using both the numerical and the UGO method. Choose another file and change its ownership using chown. Use the find command to find all the files that with the SGID bit set. So I basically did most of this exercise anyways. So that's just a basic exercise so you understand what's going on. I mean, I like this book. Now, what I would recommend is you set up a Try Hack Me account. It's like $40 a year or something. It's like really cheap. I mean, or you could do the free account. I think there's a free one that lets you do some stuff, and they have privilege escalation practicing on their online VM, right? And so, let me see real quick. Is it Try Hack Me? I think it is Try Hack Me. And I pay for my yearly membership. I haven't got on here in a long time, but I used to be top 3%. It must be growing. Anyways, so let's go here and learning path. Let's see what they got. And so with that, what we learned, we have a better understanding of it. Now we can come in here and actually practice it. I mean, that's what's cool about Try Hack Me. And you don't have to hack into it to get. That's all stupid. Hack the box. I don't know. I never used it, but I heard you got to hack into it first, even, which is ridiculous if you don't know how to hack. And that's probably what you do after you've played around with this one for a while. But let's search for privilege escalation. So look, it's free. So this one's free. So this privilege escalation one is free, but I think the free account you can only do it for an hour a day or something. But I've done it already. See, I completed this stuff, but That's why I know about it. This is so awesome. What is privilege escalation? See, and it tells you enumeration, and then you can, it tells you, what to do, I guess, to start, you're looking at pseudo list. The same thing we just did in that. etc password, and then it's gonna have you like, use tools like netstat to what, set up a listening thing, or I don't know. It goes deep into it, right? You're using netstat. You, yeah, it goes deep into it. So you're trying to find the flag right here. Man, I don't remember how deep. See, that's why I don't. Here it is. Privilege escalation SUID. So this is showing you how to do it with the SUID advantage that we just went through. See, it's making you find the. It's giving you a better command here, and same thing we just did, but a better command to find it, I guess. And then it shows you how to actually escalate here, right? And taking advantage of it. It's awesome. I had a lot of fun doing it. I just, here's another one, sudo. So yeah, after you read this, give that a try, and then you'll have like a better understanding. See, that's the thing though. Like, try hack me goes really deep into techniques, and sometimes you'll do it and you'll figure it out, but then it's like, well, I'm lost, it's too much information. It's better to start at the basics right here. So you start at the basics here and you read about it and you go, oh, and then you do your try hack me, and then you go to your SUD one and you're going, oh, this is cool, I can do it this way, and this is how they do it. That would be my advice. All right, next chapter is going to be that process management. So this was Hack the File. I hope you enjoyed the video, and I'll see you in the next video. Have fun.